Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 7, Reflection of Light. We will be discussing lateral inversion and images formed in a pair of mirrors. Also, we will be discussing about the uses of plane mirrors. We will solve questions from exercise 7A and 7B. Are you ready for the session? Let's begin. Lateral inversion. So, in front of a plane mirror, when you stand, you will be feeling that the left will be appearing as right and right will be appearing as left. For example, okay, so you are standing in front of a plane mirror. Here you have a plane mirror. I am standing here. Okay, I am lifting my right hand. Okay, so if your friend is standing in front of you, okay, two cases you have to imagine. You and your friend are standing opposite to each other. Okay, so both of you are lifting your right hand, which means you will be able to see that from here it is this hand that you are raising. From the opposite, that is your friend who is standing in front of you will be lifting in such a way that it is this hand. Okay, so the right hand of his will be lifted. This is how it will be like. So both of you are standing opposite to each other. Okay, now consider your image. That is, you are standing in front of a plane mirror. You will be able to see the image of yourself. Okay, so when you lift your right hand from here, what it appears is, in the mirror, it will be like, this is how it is lifted. So you can just try this. Lifting your right hand, you will be feeling that the image formed. Your image will be lifting his left hand. Okay, so why is this difference happening? This is because of lateral inversion. The plane mirror is producing an image that is laterally inverted. Left appears right and right appears left. So here you can see, okay, if you are having a letter D. Okay, letter D is your object. So what has happened when the image was formed? It is not that the letter D is the object and this is how the image is. Is it happening? No, right? What has happened? Left and right has changed. Okay, so this is the left side, this is the right side. So here what has happened? Right side, that is the bent portion, has come to the left. Okay, the bent portion has come to the left. And the straight part, which is the left side, has come to the right. So this difference has happened. Okay, this is because of lateral inversion. Okay, the interchange of the left and right in the image of an object is called lateral inversion. Because of lateral inversion only, when you lift your right hand, it will be appearing like you are lifting your left hand. Okay, so first property, the lateral inversion produced by a plane mirror is similar to the inversion that occurs on a blotting paper used to dry ink while writing. Okay, just imagine, I'll just show you something. So here what you have to do is, you can just try, if you have an ink pen, take a sheet of paper. Okay, take a sheet of paper. Now what you have to do is, put some ink on it. Okay, put some ink on the sheet of paper. You might have tried in smaller classes. So after putting an ink, fold the paper. Okay, when you fold the paper and open, you can see one is the left portion and the other is the right portion. Let's say an image is formed. That is, ink will get spread. Okay, ink will get spread. So you will be able to see, let's say, this is how the left side is. Okay, then right side also will be in the same way. Okay, this type of an image is formed. What is the difference? So here we have left, here we have right. Okay, so here in the right side, this is closed, that is a straight. Okay, so left side of the image formed will be straight and the right side, this design will be there. Okay, for example, let's say ink you have dropped and you got an image which is in this way. Okay, this is your object side. So how will it appear on the image side? After folding, when you open, you will be getting the same way. Okay, only thing is that left and right has shifted. Clear? Now the second, the lateral inversion of letters such as A, H, I, M, O, T, U, V, W, X and Y is not noticeable. Just let us try. If you take the letter A. Okay, here left side is, this is how the left side is and this is how the right side is. You keep a mirror and try to get the image. You can just try it. Write A on a white sheet of paper, hold it in front of a mirror. When you get the image, it will be same thing. Okay. But when you take B, this is how you write B. Okay. When you get the image, here this is left, this is right. It should change. Okay. So this is how B will appear in the mirror. When you take C, you will be getting image this way. When you take D we have already discussed. This is how D is. Okay. D will appear in this way. Left hand, right side shifted. E. Next, F. What about G? This is how G is. It will become this way. Next, when you take H, how is the image? Same thing you will be getting. There will be no change. I, again same thing you will be getting. Next is J. This is how J is. So, image will be this way. K. This is how K is. Image will be this way. Next, L. This is L. This is how L will be. What about M? Same thing you will get. Okay. Next, N is this way and the image will be this way. Okay, laterally inverted image. Next, O. Same thing you will get. P. There is a difference. Q. There is a difference. Next, R. Image will be this way. S. Image will be this way. What about T? Same thing you will get. U. Same thing you will get. V. Same thing you will get. W. Same thing you will get. X. Same thing you will get. Y. There is a difference. Okay. What about Z? There is a difference. Okay. So, for letters A, H, I, M, O, T, U, V, W, X and Y. Okay, there is a difference. So, Y, if you are writing like this, then there is a difference. If you are writing Y in this way, normally in prints and all, you will be getting Y in this way. Okay, so there won't be any difference. So, for these letters, there is no difference. The laterally inverted image, the image and the object will be the same thing. Third point, it is because of lateral inversion that it becomes difficult to read the text of a page from its image formed by a plane mirror. Next, when you take the case of an ambulance. Okay, ambulance. Have you seen an ambulance? So, on the board, is it this way it is written? No, right? There is a difference. So, why the difference is there? Because we know that left and right should be shifted. Okay, so when a person is driving and behind him there is an ambulance, if he should read it as ambulance, what should happen? Because there is a mirror in front of him. Okay, he will be checking on the mirror, rear view mirrors. So, when checking, he should be able to read ambulance. For that, what should be that? On the board, it should be written in such a way that he is able to read ambulance properly. Okay, so the laterally inverted image is how it is written on the board of an ambulance. Okay. For example, so here if you have a mirror, okay, if this is A, N, then the image should be N, A. N will be coming first. So, in the case of an ambulance, how it will be written? It will be written as E, C, N, A, L, U, B, M, A. This is how it will be written. Only then you will be able to read ambulance on the plane mirror. Okay, you will be able to read it as ambulance. Clear? The left and right will be shifting. Understood? So, this is the third property. Next, the image formed by a spherical mirror is also laterally inverted. So, this is all the case about plane mirrors. So, spherical mirrors, when you take the case of vehicles, in case of vehicles, the railway mirrors, their spherical mirrors will be used. Okay. So, in case of spherical mirrors also, inverted images will be formed. Laterally inverted images will be formed. Okay. That is left and right will be shifted. So, these are the properties of lateral inversion. What is lateral inversion? What are the characteristics of image formed by a plane mirror? Okay. So, these are the characteristics. First one is upright. Upright is also called as erect. So, here you can see this is how the object is and the image is also in the same way. erect image is formed. So if the object is this way, the image will also be the same way. This is the first property. Next, it is virtual. What is virtual? It cannot be obtained on the screen. This is what we call as virtual images. So image which is formed by a plane mirror can never be obtained on the screen, and it is always formed behind the mirror. So it is a virtual image. Okay, of same size as the object. So here you can see this is the object and this is the image. So when you measure, you can see that they are of the same size. Next is they are laterally inverted. Left changes to right and right changes to left. Also there are other properties, that is, if you have a mirror here, okay, let us say at 2 centimeter distance you had an object. The image will be formed at 2 centimeter. That is, here the object's distance from the mirror is 2 centimeter. Then the image distance from the mirror will also be 2 centimeter. That is, they are at equal, object and the image. When you measure the perpendicular distance from the mirror, on measuring you will be able to see both of them are equal. We have proved this. Okay, we have proved this. Now what happens is, let's say the object moves from the mirror by 2 centimeter, okay, away by 2 centimeter. What happens to the image? Image will also move by 2 centimeter. If 1 centimeter object moves closer to the mirror, what happens? The image will also move closer to the mirror by 1 centimeter. Okay, let's say D is the distance of the object from the mirror, then D will be the distance of the image from the mirror. In that case, 2D will be the distance of the object from the mirror. If the object is moving towards or away from the mirror by X distance, then the image will also move from the mirror by X distance, which means what is happening? If it is moving towards, if the object is moving towards the mirror, in that case, the distance between the object and the mirror is reducing by 2x. Okay, x is moved by the object, x is moved by the image, which means it is reducing by 2x. If they are moving away, then the distance is increasing by 2x. Okay, distance moved is increasing by 2x. Understood? So these are the properties or the characteristics of the image formed by a plane mirror. One more thing, let us say the object is moving towards or away from the mirror with a speed v. Okay, in that case the image will be moving towards or away from the mirror with the speed 2v. Okay, if object is moving at a speed v, then the image will be moving at a speed 2v. Clear? Let us take an example. An object is at a distance 25 centimeter in front of a plane mirror. So here we are considering a plane mirror. This is the plane mirror. At a distance of 25 centimeter, we have the object. The mirror is shifted 5 centimeter away from the object. Okay, away from the object means the mirror is moving this much distance, 5 centimeter distance. Okay. Find the new distance between the object and the image. Okay. Initially, where will the image be formed? Here the object is at 25 centimeter. This is a mirror M dash. In that case, image will be formed at a distance 25 centimeter. Okay. Now what is happening? The object is at the same point. What has happened? The mirror is moved by 5 centimeter. When the mirror moves by 5 centimeter, okay, what is the distance of the object from the mirror? Okay, this is the new position. It will be 25 centimeter plus 5 centimeters. So, distance of object from mirror is equal to 25 plus 5, 30 centimeter. In that case, the distance of image from mirror, what will be the distance? It will also be equal to 30 centimeter. Okay, so image will be formed somewhere here. Okay, this distance is 30 centimeter. The new distance between the object and its image we have to find. Okay. The new distance between the mirror and the Image we know. We have to find the new distance between the object and its image. So here we have object which is at 30 centimeter and image is at another distance of 30 centimeter. So distance of object, new distance of the object from image will be equal to 30 centimeter plus 30 centimeter, which is 60 centimeter. Okay, next the distance between the two positions of the image. How to find the distance? So let us say we are starting this point O, that is where the object is, we are taking as the origin. Okay, so till the first mirror, what is the distance? 25 centimeter. Okay, so first image is formed at, this is 25 centimeter and this distance is 25 centimeter. So from O to I, what is the distance? That is equal to total 50 centimeter. O we have taken as the origin. From O, with respect to O, we are measuring all other things. Okay. Next mirror is at a distance of 30 centimeter from O and the image is again at a distance of 30 centimeter from the mirror. Okay, which means 30 plus 30, 60 centimeter. O I dash is equal to 60 centimeter. So the difference will be equal to OI dash minus OI, which is equal to 60 centimeter minus 50 centimeter, that is 10 centimeter. Okay, so the difference is 10 centimeter. Image is formed in two inclined mirrors. We know how image is formed in a case of mirror. If you have inclined mirror, what does inclination means? You know this? So here, let us consider, take the case of a book. Okay, so here I am opening this book. Okay. You can see two parts. This is the first part, this is the second part. Consider that this is the first mirror and this is your second mirror. Okay, I can place this in any way. So here if I am holding in this way, you can see that they are perpendicular to each other. Okay, the angle between the two mirrors is 90 degree. When I hold it in this way, they are perpendicular to each other. So when I hold it this way, in this way, you can see the angle is 60 degree. When I hold little more closer, you can see that angle becomes 30 degree. If I place like this, angle is 0 degree. When I open it completely, what happens? Angle becomes 180 degree. So here, this angle we call the inclined angle. When you take two mirrors, they can be kept at any angle. Okay, so what happens is, you take two mirrors and place an object. They are kept at an angle. Okay, let's say 30 degree, 60 degree or 90 degree, whatever it is. And an object is placed between them. Okay, you can see the image. So here you can see only two mirrors are there. How many candles can you see? So this is the first mirror, A. And this is the second mirror, B. Let's say that they are at an angle 90 degree. Okay, so here we have the object. Normally, in one mirror, how many image will be obtained? When you have a plain mirror in front of you, you can see your image. Only one will be there. So, in this mirror, you can see one image. So, A. In A, you can see one image, I1. Okay, so this is the object. So, here, this is the second mirror. Okay, in the second mirror also, you can see the image. Here, the object is, here we have a plain mirror. Behind the mirror, the object image will be obtained, I2. Okay. Now, what about this? What about this? Where did this come from? So, here you can see, even though two mirrors are there, only we are considering two mirrors, it is not that only two images of the object is obtained. Many images are obtained. In this case, you can see three images are obtained. We don't know where this third has come from. Okay, so here what happens is, the image that is formed in the first case, okay, it acts as an object for the second mirror. Okay, image that is formed from the first mirror will now act as an object for the second mirror. And then when it acts as an object for the second mirror, another image will be formed. Okay, so this is what happens. So, the object and the image formed by the two inclined mirrors lie on the circumference of a circle whose centers lie at the point of intersection of the two mirrors, and the radius is equal to the distance of the objects from the point of intersection. So, we have understood that in this case multiple images are formed. Okay, so when you consider these images, okay, you can see that they all lie on the same circle. When you draw a circle, you consider a circle, all of the base of these images will be on the same circle, circumference of the circle. Okay, and the center of the circle will be the point of intersection of the two mirrors. Okay, so two mirrors, when they are kept inclined, there is a point where they are inclined. Okay, there is this is a point. So this is a point of intersection. This point will be the center. Okay, now the radius. What is the radius? The radius is the distance from this point of intersection of the mirrors to the object. This distance is the radius. Okay, so when you take two mirrors and they are kept inclined, you have understood that many images are formed. N number of images will be formed. Now, what is this n number? How this n number is obtained? Let's see. Number of images formed depends on the angle theta degree between the two mirrors. First, we'll have to find an n value. N is equal to 360 degree divided by theta degree. Depending on this, we can say the number of images. Okay. So, first case that we are considering is if the angle between the mirrors is such that n value is equal to 360 divided by theta degree is an odd number. Okay. So, we are considering a case when this n value is a odd number. In that case, first is when. Okay. First is when this value, that is the object, is placed asymmetrically. And the second is when the object is placed symmetrically. Number of images. Okay, what does asymmetrical and symmetrical means? Okay, so now consider we have taken the case of candle. In that case I have said that the angle is 90 degree. So how many images were there? We have seen there were 4 images. Okay, we are able to obtain 4 images. Okay, so now here you are able to see that 360 degree by 90 degree is equal to 4. Okay, this is an even number. Okay, this is applicable only when it is an odd number. So, if you are taking a case where you are getting an n value that is an odd number, in that case, what happens is, you will discuss about asymmetrical case and symmetrical case. If this is how the mirrors are. Okay, first mirror, second mirror. Okay, now I am drawing a perpendicular bisector to it. Okay, so what is a bisector? If you take a compass, measure some length, okay, let's say some 2 centimeter you are measuring. Okay, keep the edge of the compass here, draw an arc. Okay, keep the edge now here at a 2 centimeter, draw an arc. Okay, draw a line. This line we call the bisector. This is a bisector of the angle. So, if this is 90 degree, this part is 45 and this part is 45 degrees. Okay, so it is bisected. Now, if you are keeping the object on this line, on the bisector, okay, if your object is kept on the bisector, then we call that as what symmetrically means. Okay, asymmetrically means not on the bisector. Okay, you are not placing the object on the bisector. So, if it is placed, object is placed asymmetrically, in that case, the n value you will obtain. Okay, you will get an n value, an odd number. This will be the number of images. Okay, number of images will be n. Okay, now the second case, if you are placing the object on the bisector, in that case, the number of images will be n minus 1. Okay, for example, if you are getting n value equal to 5. If you are placing the object anywhere other than the bisector, you will be getting 5 images. And if you are placing an object on the bisector, you will be getting n minus 1 images, which means 5 minus 1 equal to 4 images. Okay, so this is the first case when n is equal to 360 degree divided by theta degree is an odd number. Let us take an example. If the angle between two mirrors is 72 degree, then what is the number of images formed? Okay, here what is theta? Theta is equal to 72 degree. Therefore, n will be equal to 360 degree divided by 72 degree. Okay, 72 into 5 is 360, which means n value we are getting 5. Okay. We need to find what the number of images is. Number of images will be equal to 5 if the object is placed asymmetrically. And the number of images will be n minus 1, which is equal to 5 minus 1 equal to 4 if the object is placed on the bisector, if the object is placed symmetrically. Okay. Object placed symmetrically, you will get 4 images, and object placed asymmetrically, you will get 5 images. So here in this case, what is happening is 2 images will overlap. Okay, 2 images will overlap. That's why you will be getting only 4 images. Clear? Now the second case, if the angle between the mirrors is such that n is equal to 360 degree divided by theta degree is A1. Now take the case of candle. In case of candle, we have seen there are 3 images. Okay, there are 3 images. So what is the n value here? If we take theta is equal to 90 degree, n value will be equal to 360 degree divided by 90 degree, which is equal to 4. Okay, so when the n value is an even number, okay, the number of images formed will be n minus 1. Whether the object is placed symmetrically or asymmetrically, in all the cases you will be getting n minus 1 images. Okay, it is not necessary that object is on the bisector or away from the bisector. Whatever it is, you will be getting n minus 1 images. So in the case of candle, how many images we got? We got 3 images. Okay, what is the n value? N value is 4, which means n minus 1 will be equal to 4 minus 1. Okay, therefore the number of images will be 3 images. 3 images. Understood? So if n is equal to 360 degree divided by theta degree is an odd number, only then n will be the number of images formed if it is not placed, the object is not placed on the bisector, or if it is not placed symmetrically. Second example, if the angle between two mirrors is 60 degree, then what is the number of images formed? Okay, how to find? Here theta is equal to 60 degree, we have n is equal to 360 degree divided by theta degree, that is 360 degree divided by 60 degree, which is equal to 6. Okay, what is the n value here? You can see that the n value is equal to 6. 6 is an even number. When n value is an even number, the number of images formed will be equal to n minus 1. So here n minus 1 will be equal to 6 minus 1, which is equal to 5. Therefore, we can say 5 images are formed. 5 images are formed. Images formed in a pair of mirrors placed parallel to each other. So parallel, when two lines are parallel, what is the angle between them? Theta will be equal to 0 degrees. Okay, so here what is the n value? N value will be equal to 360 degree divided by 0 degree. Okay, 360 by 0, anything divided by 0 will be not defined, or it is infinity. Okay, what does it mean? When two mirrors are kept parallel to each other and an object is kept between them, you can get infinite number of images. So just look at this case. You can see that two mirrors are taken and a toy is kept in between. You can see infinite number of the images of the toy. Okay, have you heard about infinite ladder? In this case, this is first plane mirror, this is the second plane mirror. Okay, so between that, you place a ladder which is made. Okay, with thermocol or something, make a ladder and place. So when you look from here, okay, you will be able to see that this ladder will be extending down till infinity, extending up till infinity. Okay, so the length of the ladder cannot be measured. In that way, it will extend. Okay, so this is an illusion. This is a feeling that the ladder is never ending. Okay, what is happening in all these cases? So here you can see AM is the first mirror and BM dash is the second mirror. They are facing each other. Okay, they are kept parallel to each other. So P is an object. Okay, so this P is an object. first light ray from P is striking AM. Okay. First light ray is striking AM. What is happening? It is getting reflected. Okay. It is getting reflected. Second light ray. This is the second light ray. It is also getting reflected. So, we know that in the case of a plane mirror, a virtual image is obtained. Where is the virtual image obtained? Okay. Image will be obtained. You have to just extend these light rays. The reflected rays you have to extend. At this point, I1 is the first virtual image. You will feel that the image is here. Okay. Similarly, from P, light rays will strike M1. Then what happens? It will get reflected. It will get reflected. When you extend it backward, at I1, I' you will be getting a virtual image. Okay. Now, this I1 will now act as a object for BM dash, mirror BM dash. Okay. So, light rays from here will go strike the mirror BM dash. What happens after reflection? These are the incident light rays. After reflection, this is the first ray, this is the second ray. So, after reflection, these reflected rays can be extended backward. They are meeting at a point I2. So, image of I1 is formed here. That is I2. Okay, I2 is formed. A virtual image is formed. Okay, similarly from I dash, light rays will strike. I dash will act as an object for AM, mirror AM. So, light rays will strike and the image will be formed. Okay, reflected rays will be extended backward and the image will form, which is I double dash. Okay, now from I dash and I double dash are formed. Okay, so from there light rays will go strike the mirrors, strike the different mirrors. Again, this will continue and multiple. You can see I3 formed. How is I3 formed? The light rays from I2 are falling on the mirror AM. First, it was, that is from I1, the light rays falls on B, M1. Then, after reflection, the light rays now falls on AM. Okay. So, here, when it falls on AM, gets reflected, extended backward, I3. We are getting a virtual image I3. So, this will continue. So, what happens is, in each case, okay, when you take the images, you can see that the image will go, the brightness of the image will decrease. Okay, therefore you won't be able to see infinite number of images. Why? Because after some steps, what happens is brightness will completely reduce. Okay, so this is what happening. So first object will be the brightest. Some of the light will get absorbed by the mirrors. Okay, because of that the brightness will keep on decreasing. So this is a case when the mirrors are held parallel to each other. Infinite number of images are found because 360 degree divided by 0 is infinity. Okay, we are not able to see this much images. Why? Because the brightness will be decreasing and only up to a few images we will be able to see. Now, where this is used? In case of showrooms, in showrooms like in jewelleries or in fruit stalls, vegetable stalls, and you are able to see this type of mirrors. Why they are kept? To make the room, that is to make that room, showroom attractive. So, what is happening? Due to multiple reflection, you will be able to see many like gold. Then gold will be, or everywhere you will be able to see gold or fruits, whatever it is. Next, in barber shop. In barber shop also you have seen this. In beauty parlors and barber shops also, this type of, that is mirrors are kept parallel to each other. Okay. So, multiple, this is called multiple reflection. You will be able to see multiple reflection. Images found by a pair of mirrors placed perpendicular to each other. We have discussed the case of candle. In case of candle, when they are kept perpendicular, angle is 90 degree and 3 images are obtained. Okay, let's see what is happening in this case. So, here we are considering two mirrors, OA and OB are the mirrors. Okay, here we have an object P. This is the object P. So, first we are considering light rays from object P striking the mirror OB. Okay, this is the first ray and this is the second ray. First ray and second ray. After reflection, what is happening? You can see the reflected rays. Okay, these are the reflected rays. When extended backward, you will get the image. So, P2 is the image. Okay. So when OB mirror is considered for the object P, image is P2. Okay. Now take the other case. OA mirror is considered. Object P. Okay. Light rays from object P is striking OA. Okay. It will get reflected when extended backward. In that case, the image will be formed at this point. This image we are taking as P1. Okay. So P1 is the image. Now P2 is a virtual object. We call it as virtual object. P2 will act as a virtual object for the mirror OA. So light rays from P2 will strike the mirror OA. It will get reflected. So here it is getting reflected. This is a reflected ray. This is another reflected ray. Extended backward. So when extended backward, you are able to see the virtual image is formed. P3 is the image formed. Here P3 is formed. Similarly, we have seen that P1 is formed. Okay. Now, P1 will act as a virtual object. It will act as a virtual object for the mirror OB. Okay. So, light rays from P1 will strike the mirror OB. After reflection, so this is how it will go. After reflection, the light rays will be in this direction. When extended backward, you will be getting an image at this point. So from here, this is acting as a, here we have the mirror, light rays go, strikes the mirror, you will be getting the image here. Okay, this is a virtual image which is formed, which we can name as P4. So you can see that P3 and P4 are at same point. Okay, so total, how many number of images are obtained? You can see P1 is the first image, P2 is the second image, P3 and P4 are the same, which means P3 is the third image. So 3 images are obtained. So we know that if n is equal to 360 degree divided by theta, that is 90 degree in this case, is equal to 4, which is an even number, the number of images formed will be n minus 1. What is n minus 1? 4 minus 1, which is equal to 3. 3 images will be formed in this case. So 3 images are obtained when the mirrors are kept perpendicular to each other, and you have seen that when the mirrors are kept parallel to each other, in that case, infinite number of images are obtained. Okay, this is the case of the candle that we have discussed. Now, we'll be discussing the uses of plane mirror. Where do you use plane mirror? In our daily life, we all use plane mirror, right? So, first application is, the most common and wide use is as a looking mirror glass. Okay, we just can find how we look by looking at a plane mirror. Okay, that is a normal mirror that is in your bedroom and washrooms and all. The plane mirrors are being used. So, this is the first use. Second use of plane mirrors in the optician's room to increase the effective length of the room. So, here what happens is, here there is a signboard and this is a plane mirror. So, plane mirror is kept on the front fold. Okay. Then the signboard will be behind. So, person will be standing between it. Okay. So, here he will be able to see the image of the signboard. That is, it is about double the length. Actually, the signboard will be at a distance of x from him, but he will feel like it is at a distance of 2x because the plane mirror is in front and the image of the signboard is what he sees. Okay, so this is the second application. Third application, in the barber shop for seeing the hair at the back of head. So here you have seen that in barber shops and beauty parlor, front one mirror will be there so that you can see the front side, and back another mirror will be there. Okay, that is 2 parallel mirrors. Okay, here when you have a mirror at the back side, you will be able to see the back side. So here the person is sitting in front of a mirror. Okay, you can see the barber is holding a mirror behind him. Okay, now he is able to see the image here. Back side is being seen here. So even you can try this. Take a mirror, go stand in front of another mirror. Okay, hold the mirror in such a way that you should stand in such a way that you are holding a mirror in your hand, and you will be standing in such a way that another mirror is on the back side. Okay, so you will be able to see in this mirror which you are holding in your hand, you will be able to see the image of your back side. Okay, so this is the third application. Next is, in periscope, 2 parallel plane mirrors, each inclined at 45 degree with vertical walls are placed facing each other. So here you can see, okay, this is the object. And this is what a periscope is. A person is standing here. Okay. Standing here, he is not able to see the object which is at a height normally. So, he can use a periscope to see this object. So, how does he see the object? What is happening here? Normally, we will be able to see object only which is along the line of sight. Yes. Here you can see the object is at a greater height, but you want to see the object. So, a periscope can be used. Here what happens is, this is the object. You can see one plane mirror, two plane mirror. Okay. Two plane mirrors are there. They are at an angle 45 degree. Okay. So, here the light rays from the object will strike. Okay. It will be striking. So, the angle of incidence will be 45 degree. Angle of reflection will also be 45 degree. So, here the first ray is reflected ray, second ray is reflected ray. Okay. These reflected rays will now act as incident rays for the second set of plane mirrors. So, here we have parallel mirrors. Okay. Now, they will get reflected. Okay. They will get reflected. Okay. Because of this reflection, the person is able to see the object which is at a height using a periscope. So, this is the fourth application of plane mirror. Fifth one, in a kaleidoscope. So, have you seen a kaleidoscope? So, in case of kaleidoscope, you can see very different beautiful patterns. So, how to make a kaleidoscope? To make a kaleidoscope, we have to take 3 rectangular plane mirrors of the same size. Okay. Now, they should be kept in such a way that 3 plane mirrors were taken. We have to keep in facing each other. We have to keep it in such a way that angle between each is 60 degree. Okay. So, the front face, when you take, it will look like a triangle 60 degree. Each angle will be 60 degree. It will be an equilateral triangle. Okay. We have to keep in this way. After that, you have to, one end you have to keep a glass and then put some beads into it. When you look through the other end, you will be able to see different hexagonal pattern. Hexagonal patterns are obtained. So, here you can see 2 mirrors. This is the angle of inclination 60 degree. Here you can see the beads. Okay. Now, the images are formed. Different images are formed. So, you are getting a hexagonal pattern. Now, when you keep rotating this kaleidoscope, you will be getting different patterns. The beads will shift their positions and different patterns are used. Okay. So, in a kaleidoscope, 3 plane mirrors inclined with each other at 60 degree are used. Okay. Next, plane mirrors finds application in solar heating devices. Solar heating devices include solar cookers, solar water heaters, etc. So, here what happens is sun rays which falls on the plane mirror are reflected on the object. Okay. So, that the object gets heated, the object gets cooled. So, this is another application of plane mirror. Question number 2 of exercise 7A. A man standing in front of a plane mirror finds his image at a distance 6 meters from himself. What is the distance of man from the mirror? Okay. So, a man standing in front of a plane mirror. Consider a plane mirror M dash. Finds his image at a distance 6 meters from himself. So, let's see here the man is, which is object, here the image is. Okay. So, what is given? He finds his image at a distance 6 meters from himself. So, OI is equal to 6 meters. This distance is 6 meters. What is the distance of man from the mirror? Man's distance from mirror we have to find. So, we know that. Okay. So, if you take this point as some N. Okay. N is a point. That is on the mirror. Okay. So, when you draw a line that is passing through the object and image, it will coincide with it. Okay. So, we know that ON is equal to IN. What is the reason? ON is equal to IN because the distance of the object from the image, that is a perpendicular distance of the object from the mirror is equal to the perpendicular distance of the image from the mirror. Okay. Therefore, ON is equal to IN. Also, ON plus IN will be equal to 6 meters. This total distance is 6 meters. We need to find the distance of man from the mirror, which means we have to find what ON is. Okay, so we have ON plus IN is equal to 6 meter and IN is equal to ON. Substituting, you get ON plus ON is equal to 6 meter. 2 times ON is equal to 6 meter, which means ON is equal to 6 meter divided by 2, which is 3 meter. Therefore, the man's distance from mirror. Man's distance from mirror is equal to 3 meters. 3 meters is the distance. Question number 3 of exercise 7a. An insect is sitting in front of a plane mirror at a distance 1 meter from it. Where is the image of the insect formed? The insect is sitting in front of a plane mirror. So this is a plane mirror. Insect is sitting in front of the plane mirror at a distance of 1 meter from it. So 1 meter distance we have the object. Here the object is the insect. Where is the image of the insect formed? Image will be formed on the opposite side of the mirror, which is again at a distance of 1 meter. Okay, at a distance of 1 meter from mirror. At a distance of 1 meter from mirror. Next, what is the distance between the insect and the image? Here we have the insect and here we have the image. What is the distance? 1 meter is the distance of the object from the mirror. 1 meter is the distance of image from the mirror. Therefore, the total distance will be equal to 2 meters. So, distance of image from insect is 2 meters. 2 meters is the distance. Question 4 of exercise 7a. An object is kept at 60 centimeter in front of a plane mirror. So here we have a plane mirror. The object is kept at 60 centimeter in front of a plane mirror. If the mirror is now moved 25 centimeter away from the object, okay, by 20. So this is M dash. It is moved by 25 centimeter. How does the image shift from its previous position? So what is happening to the image? Initially where is the image formed? So here we have the mirror, here we have the object, then the image will be formed somewhere here, which is again at a distance of 60 centimeter from the mirror. Okay. Now, when this shifting is done, okay, that is the mirror is shifted by 25 centimeter away from the object. Now, this total distance, object's distance from the mirror will be equal to 60 plus 25 centimeter, which is 85 centimeter. Where will the image be formed? Image will be now formed at a distance of 85 centimeter from the new position of the mirror. Okay, 85 centimeter distance we will have the image formed. Okay, how does the image shift from its previous position? So now we have OI. OI is the initial distance of the image from the object. This distance is equal to 120 centimeter. What about the new position? Okay, this is the initial position of image and this is the new position of image. So here we will be having 85 centimeter, this part 85 centimeter. 85 plus 85, which is 170 centimeter. So the new image is at a distance of 170 centimeter from the object. Okay, so the shift of the image can be determined, which is OI dash minus OI equal to 170 centimeter minus 120 centimeter equal to 50 centimeter. So the image will shift by 50 centimeter, by a distance of 50 centimeter. Question 5 of exercise 7a. An optician, while testing the eyes of a patient, keeps a chart of letters 3 meters behind the patient and asks him to see the letters on the image of chart formed in a plane mirror kept at a distance 2 meters in front of him. At what distance is the chart seen by the patient? Okay, so here let's say this is the patient. Okay, there is a chart behind her. Okay, so this is a chart behind her. We are given that the chart is 3 meters behind her. Okay, This distance is 3 meter. Okay, what else is given? Him to see the letters on the image of chart formed in a plane mirror which is kept 2 meter in front. So, in front of it at a 2 meter, we have the plane mirror. Okay. At what distance is a chart seen by the patient? At what distance does she see the chart? Okay. So, here the distance of the object from the plane mirror. What is the distance? So, here 3 meter is the distance of the chart from the patient and the distance of the plane mirror from the patient is 2 meter. Okay. Which means the total distance of the object from the plane mirror will be equal to 5 meter. Where will the image be formed? Image will be formed at 5 meter from the plane mirror. Okay. So, here the chart, image of the chart is formed. Okay. Which means the distance between the object and image. Distance between object and image, OI, is equal to 5 meter plus 5 meter, that is equal to 10 meter. Here we have to find at what distance does the patient sees the chart, which means we have to measure the distance of the patient from the image of chart. This distance we have to measure. Okay, total distance is 10 meter. Now we have to subtract the distance of the patient from the object. PO is equal to 3 meter. Okay, then you will be getting PI, the distance of the image of chart from the patient. Okay, that is equal to OI minus PO, 10 meter minus 3 meter equal to 7 meter. So, 7 meter is the distance of the patient from the image. At a distance of 7 meter, the patient is able to see the chart. Clear? Now, let us do questions from exercise 7B. Question 1 of exercise 7B. State the number of images of an object placed between two plane mirrors formed in each case when the mirrors are inclined to each other at 60 degree, at 90 degree and at 60 degree. So, when the angle is 90 degree, theta is equal to 90 degree, n value will be equal to 360 degree divided by 90 degree, which is equal to 4. N value is 4, which is an even number. If n value is an even number, then what is the number of images? Number of images will be equal to n minus 1, which is 4 minus 1 equal to 3. Okay. Now, the next one. Here theta is equal to 60 degree. Therefore, n will be equal to 360 degree divided by 60 degree, which is equal to 6. N value is 6, which is an even number. If n is an even number, then the number of images will be equal to n minus 1, which is equal to 6 minus 1. Therefore, 5 images. Question number 2 of exercise 7B. An object is placed first asymmetrically, second symmetrically between two plane mirrors inclined at an angle of 50 degree. Find the number of images formed. Here angle theta is equal to 50 degree. Okay. What is n? N will be equal to 360 degree divided by 50 degree. 360 by 50, cancelling zeros. 36 divided by 5. You get 7.2. Okay. So, we have to round it to a whole number. 7.2, nearest whole number, when you round you will be getting 7. So, n value can be 7. If n is equal to 7, okay, first case is asymmetrically. Asymmetrically means we are not placing the object on the bisector. Okay, when asymmetrical case, the number of images will n be equal to n. That is 7 images are there. Okay. Now, if it is symmetrically, in that case, it is on the bisector. Object is placed on the bisector. N minus 1 number of images will be formed. That is 7 minus 1, which is equal to 6 images. 6 images. Got it? Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.